Okay, so this is about priority. Now we are going to talk about R and S nomenclature in wedge dash. Wedge is this bond. This is wedge. Dash is this one. So I will discuss case 1. I am saying when lowest priority is attached to dash, then move 1 to 2, 2 to 3. If it is clockwise, then R, and if it is anti-clock, then S. Suppose we have a compound this one, and we have to find R and S form in this compound. So how can you check R and S form in this compound? So listen me. First of all, decide the priority according to CIPS. As you can see, fluorine is 1, nitrogen is 2, carbon is 3, and hydrogen is 4. So which one is your lowest priority? The number 4 position is your lowest priority, and you can see lowest priority is attached to dash, and you can see here lowest one is attached to the dash. Now we will move 1 to 2 location. So 1 to 2, this is movement like this, 1 to 2, and you can see this is going anti-clock. This is going anti-clock. So if it is going anti-clock, so we can say it will be S. So this will be S. Any doubt? Any doubt? Please tell me. It's very easy one. First of all, decide your priority and then check 1 to 2 location. If 1 to 2 movement is anti-clock, then S, and if it is clock, then R. Okay, we can take one more example. This one. This one you can see fluorine is 1, oxygen is 2, nitrogen is 3, hydrogen is 4. Now this time we have some problem. That is not a difficult one. Listen. Whenever you have 1 to 2 location, if you are going 1 to 2 and 3 and 4 is between them, number 3 priority as well as 4 is between them, you can cross your 4th priority, because 4th is lowest in nature, so you can cross this one. But number 3 priority you cannot cross. This is a rule. So I am going to see 1 to 2 location. So if you are moving 1 to 2 form, you can cross your 4th priority. And you can see this is going clockwise, so this is R. Again, listen me. I am talking about R and S nomenclature in wedge dash projection. Wedge means this solid line, dash means this line. So I am talking about case first. Case first is when lowest priority is attached to dash, then move 1 to 2 location, and if it is clockwise then R, and if it is anti then S. Suppose example A, we have 4 connectivity and I decide priority according to CIPS. Fluorine 1, nitrogen 2, carbon 3, and hydrogen 4. Hydrogen is here lowest one, and lowest is attached to the dash. So we can move 1 to 2 location. This is going anti-clock. 1 to 2 location is going anti-clock. So anti-clock, that means S. So this is S. And in the right side, suppose I'm talking about B. Here, fluorine 1, oxygen this time 2, nitrogen 3, hydrogen 4. We have to move 1 to 2 location. And you can see number 3 and number 4 is present between 1 to 2. So you can cross your fourth priority group. And this is going clockwise. So this is R. Any doubt? Please tell me. Perfect. What about this one? Please turn off the mic. Someone has, Okay, what about this one? R or S? Take your time, no hurry. Okay, I got 3 answer. Everyone is saying R. Someone has said S. Okay, now I'm going to check this. OH1. OH is 1. This is 4. This is number 2 priority. This is number 3 priority. So again, you have a 4 and 3 between 2, 1 and 2. So you can cross your fourth priority. This is going clockwise. So if it is going clockwise, you can say it will be R. So answer should be R. Perfect. Now I am going to discuss second case. Case 2. If lowest priority is attached to wedge, then move 1 to 2, 2 to 3. If it is clock, then S. If it is anti, then R. Suppose we have this one. So you can see bromine is your 1, nitrogen is your 2, methyl is your 3, hydrogen is your 4. Move 1 to, and you can see here lowest one is associated with wedge. It means we can apply case second this time. So move 1 to 2. 1 to 2 is going anti-clock. So if it is anti, it means R. So we can say R. Any doubt? Please tell me. No doubt. And I can give you a trick to memorize this concept. Listen me. For wedge and dash projection, for wedge and dash, always memorize D A S W A R. What does it mean? It means D for lowest dash, means when your lowest priority is attached to dash. A stands for anti-clock. and S is your configuration. W means lowest wedge. Means when your lowest priority is attached to wedge. A stands for anti-clock. R is your configuration. You can ask what happens when lowest is attached to the dash and the movement is clockwise. So D, C. You know that NT is S, so clock will be R. Simple. If wedge NT is R, then clocks will be S. Simple. Any doubt about this? Please tell me. And it is very easy to memorize. Var and dash. Okay, perfect. Now we can move to the Fisher projection. This type of projection is known as Fisher projection. This is known as horizontal and this is known as vertical. So I am going to discuss case first. When lowest priority yes, someone said me, what is neither dash nor wedge for lowest priority? Very good question. In fact, I have discussed this one plenty of time with my students and some videos as well. But personally, I don't think that this is important. The reason is that R and S is not important in case of when, suppose this one. The question is here like this. This one. Now you can see this condition. The lowest one is not attached with wedge nor attached with dash. So what should we can do? So don't worry about it. I will discuss this one when I will tell you exchange rule. Then I will discuss this part. So don't worry about this. This case I will discuss when I will start exchange rule, because you can easily simplify this one. Exchange rule. There is no need to memorize another rule for this question. You can simply do this with the help of exchange method. Okay. So now finish the Fisher projection. Fisher projection case first. If lowest priority is attached to vertical axis, then move 1 to 2, 2 to 3. If it is clock, then R. If it is anti-clock, then S. You can see bromine 1, oxygen 2, nitrogen 3, hydrogen 4. Lowest is attached on the vertical axis. And we can move 1 to 2. If you will move 1 to 2, you can see this is going clockwise. So clock means R. So this is R. Any doubt? Please tell me. Very easy one. Yeah, no doubt. My request to please turn off your mic. Someone open mic. Okay. So there is no doubt in this case. So now I am going to discuss case 2. Case 2. If lowest priority is attached to horizontal axis, then move 1 to 2, 2 to 3. Clock will be your S, NT will be R. O1 nitrogen 2, carbon 3, hydrogen 4. This time you can see lowest is present on the horizontal axis. So if lowest on horizontal, move 1 to 2, this is going clockwise, so we can say it will be S. So this is S. Any doubt? Please tell me. Any doubt about this? No doubt. No doubt. Very good. Okay, now listen me. How you can memorize these rules? So VCR and HCS, simple. This is video cassette recorder, means lowest vertical. When the lowest priority is associated to the vertical and it is going clockwise, so R. And similarly, when lowest is attached to the horizontal and if it is going clockwise, then S, simple. Any doubt about VCR and HCS? No doubt. Perfect. So we can discuss some questions as well now. Okay, the question number 83. Tell me how many chiral center? Oh, sorry. The question is those that have chiral carbon. Which of the following have chiral carbon? The question is here, which have chiral carbon? Tell me. Everyone is saying C. As you can see, number one is not a chiral, zero chiral center. You know why? Because if you draw the structure of this compound, this is methyl, this is OH. At this center, definitely it has two connectivity, OH and methyl. But left and right connectivity is same. You can see this is CH2, this is CH2. This is CH2, this is CH2. So if right and left is same, only two different connectivity, that is not a chiral. So number one has zero chiral center. And now you can see option A, that is one is given, that is wrong option. B also have first combination, this is wrong. D also have first in the option, which is wrong because first is not a chiral center, it has no chiral. So only D, C is a choice where first is not included. So you can eliminate rest of the options without checking second, third, and fourth. So C should be the right choice. Any doubt? Please tell me. Because only one have no chiral center. Perfect. Now try 84. Which of the following correctly list in the group or atom order of decreasing priority? Means CIPS rule. The atomic number rule. Higher the atomic number, high will be the priority. Tell me. Okay, listen. Everyone is saying B. It means you are very sure and absolutely right. B is the right choice. Because D is wrong. Nitrogen should have high atomic number than carbon. C is wrong. Bromine should have high. O, oxygen, that is 8. Carbon is 6. So definitely oxygen has higher. I will not discuss 85 right now because it is based on different concept. What about 86? The question is here, which should be S configuration? Tell me. What about 86? Find R and S. This is about Fisher projection, and Fisher have two rules. VCR, so vertical NT will be S. HCS, so horizontal NT will be R. Bromine 1, acid 2, this is 4, this is 3. You can move 1 to 2 by crossing 4. This is going clockwise, and you know that lowest is horizontal. So horizontal clock means S. So this is S. Now, second. You can see your lowest is attached on the vertical axis. So vertical we will use, and that is going 1 to 2 by NT clock. We can cross fourth priority. So this is NT clock. So NT means S, again S. So first and second is definitely yes. So first only wrong. Second only wrong. First and second. Third only, that is wrong also, because first and second is S. So D is the right choice. There is no need to check third one. Any doubt? Please tell me any doubt about 86. Perfect. Now we are going to discuss a very important concept, and I am very sure it will help you a lot. Now I am going to talk about relationship between the molecules. So first I am going to talk about single chiral center. Whenever you have a single chiral center, it can form maximum two relationships. One is identical and one is enantiomer. And there is a two method where we can find the relationship. Identical RS method, and another method is exchange method, exchange. And here enantiomer also same, RS method and exchange method. So first I am going to discuss identical with R and S and exchange. First I am going to tell you what is exchange. This is very important line. Listen, exchange. Suppose we have a connectivity ABCD. Suppose this is my compound X, this is compound Y, this is compound Z. So if you look at X to Y, if you will move X to Y, you can see here you have the exchange between B to A only, this position. Whenever you have an exchange between means between two group at once, only one time, this is just a single exchange, one exchange. So one is an odd number. So this is known as odd exchange. This is known as odd exchange. And if you look at X to Z, the exchange between A and B as well as C and D. So you can see this is two exchange. And this is even. So whenever you have an even exchange or 2, 4, 6 type of exchange, your configuration will remain same. Means we can say even exchange, same configuration. Means suppose if X is R, then Z will also R. because this is even exchange. While odd exchange have different configuration. You can say if X is R, then it will be S. It makes sense to you? Please tell me odd and even exchange. Please. Yes, I will repeat it again. Sorry, I will repeat it again. Listen. I am giving you a very different example. You can see here. First of all, find the R and S over A. You can see chlorine 1, oxygen 2, nitrogen 3, this carbon is 4. So move 1 to 2, vertical, lowest priority is present on vertical, NT is going, so this is S. Vertical clock is R, so vertical NT is S. And if you look at this one, chlorine 1, oxygen 2, nitrogen 3, this is 4. And you can see 1 to 2. And this time vertical is again 4th. So vertical clock is R. So now you can see A and B have different configuration. And one more thing you can see, everything is same between A and B except the position of OH and NH2. OH goes to the NH2 and NH2 in place of OH. So such a type of exchange is known as one exchange, or one, you can say like odd as well, because one is odd number. So this is odd exchange. That's why I'm saying whenever you have odd exchange, it will give different configuration. Now I will do even exchange. Even means two exchange. I can keep OH vertical and H2 horizontal. And there is a one more exchange I can do, Cl with methyl. Suppose methyl here, CH3 here, Cl here. Now you can see this is two exchange. One exchange between OH and NH2 and one exchange between chlorine and methyl. And you can find the configuration, this one as well. Suppose this is C. It will also be the S1. The reason is that this is even exchange. So whenever you have even exchange, you will get the same configuration. And you can find the configuration as well. Chlorine 1, OH2, nitrogen 3, this is 4. Move 1 to 2 by crossing 4. This is going clockwise. Lowest is on horizontal. So horizontal clock S. So this is S, you can see. Any doubt? Tell me, please. Any doubt about exchange? Yes, if A is your R, then C will also be R. Okay. Because even exchange, your configuration will be the same. It will not change the configuration, while odd can change. What about this one? Tell me the exchange. If you are moving A to B, How many exchanges is there? Even or odd? Just tell me like this, even exchange or odd exchange? Listen me. How can we check? Okay. In B, NH2 is present on the top position. So I will convert NH2 over here and OH should come here. So this is just a one exchange. Means after one exchange, the structure must be like this. OH, NH2, Cl, Br. Now there is a one more exchange. Here chlorine is present in the horizontal right. So we can flip chlorine over here. OH should be here. So it means there is another one exchange. So now you can see this and this is same. And we can form the final one with two exchange, 1 and 1. That means two exchange. 2 is even number. So we can say this is even exchange, not odd. Any doubt? Please tell me. Any doubt? No doubt, I think. Yes, very good, very good. Now thing is very easy for you. Listen me, what? No need to check R and S form. Exchange is good enough to, to make the answer correct. Listen, whenever you have even exchange, your compound will be identical, simple. And whenever you have odd exchange, your compound will be enantiomer. Enantiomer. Suppose we have to find this one. This is A, this is B. My question is, what is the relationship between A and B? Tell me. What is the relationship between A and B? Yeah, I will discuss one by one. Who is the questions? Yeah, Ronak, just wait. I just, when I will discuss multiple chiral center question, then I will explain about exchange. Don't worry about it. I will make this very, very clear. Yes, this is odd exchange. So this is odd. It means this is enantiomer. So relationship will be enantiomer. Very good. And you can find your R and S. I am very sure they both have opposite configuration. This is your homework. Means you have to find the configuration of A as well as B. I am very sure it will be different. Any doubt about this one? Please tell me. Please tell me any doubt. Very good. Now my question to everyone. Can we proceed another 1 hour? I will not charge for this today. I will not charge. I just want to finish this chapter. Who is interested? Please tell me. I will not charge extra 1 hour. The same pricing. Who is interested? Thank you so much. Because I want to finish this one. Thank you so much. So as you can see, wedge and dash, then now we can solve Fisher projection as well. What is the relationship between first and second? Tell me. Even. Very good. Fantastic. What about second and third? Odd in enantiomer. Very good. What about first and third? Perfect. Now you can see this is very easy for you. And for R and S, I can tell you, if you have same configuration, suppose A is R and B is also R, then we can say it will be identical. If A is S, B is also S, then we can say identical. They both have same configuration. Any doubt about R and S method? Any doubt? In case of enantiomer, if you have one is R, then other is S, that means enantiomer. Write down. Perfect. Now I'm going to talk about multiple chiral center. Multiple chiral center. So multiple chiral center have three conditions: identical, enantiomer, and diastereomer. First, I will discuss R and S method, okay, and then I will discuss exchange method. So they both have R and S exchange, R and S exchange, R and S exchange. So less than 1 minute, you can join me again. After 1 minute, this will be disconnected. So please join me again. Okay. Now I am going to discuss R and S in identical. R and S method. Suppose you have a compound A and compound B. If this center is R and this is S supposed to be, then B, this center should be same, R, this center should also same, S, same. Then we can say this is identical. Any doubt?